Hi! We start with this video a small part of the course dedicated to surfaces in construction and architecture, with a brief introduction to some of them, which you probably know. Surfaces that are easy to recognize in many objects and buildings. One of the simplest surfaces is the cube, as this one used in the art gallery Weinshaupt in Ulm, Germany. Or the most famous surface, the Earth itself. Surfaces appear everywhere in architecture, as this one in the ACLAC Tower in Barcelona. We will see that its shape is approximately a cylinder covered by a dome, which gives the tower the form of a bullet. In a mathematical sense, the term surface defines several important things. We will consider the definition of surface as a two-dimensional subset of the three-dimensional space. One can easily recognize this definition in the graph of functions of two real variables given in their explicit form in Cartesian coordinates by describing the variable z as a function of x and y. You surely already know the plane. But this is not the topic we are interested in, since some of these surfaces generated in this way may be very complicated, as this one on the screen. On the other hand, our main interest is their relationship with curves, the objective of this course. In this sense, we can construct many surfaces as the rotation of a given curve. For instance, the paraboloid is obtained when we turn the parabola z equals x squared around the z-axis. We can also see surfaces, in a certain sense, as the union of curves. To see that, we do the intersection between the previous paraboloid and horizontal planes. For instance, the plane z equals 3. We obtain a circle of center 0, 0 and radius the square root of 3, placed at height 3, as we can observe when we turn the picture. If we intersect the paraboloid with the plane z equals a squared for any non-negative number a, as we see in the picture, we obtain circles with center 0, 0, radius a, and height a squared, as we illustrate in that picture. The higher the height is, the larger the radius is. We see them from above to observe how the radius of the circles are increasing. If we now cut the paraboloid with a vertical plane, for instance y equals 1, we get a parabola with vertex 0, 1, 1 and opening upwards, as it can be observed when we turn the image. When the vertical plane is y equals any number b, we get the parabola line the plane y equals b with vertex at the point 0 bb squared and opening upwards. By turning the image, we can compare the different parabolas in this picture. Another surface we can get by rotation is the cone. In this case, we rotate the straight line z equals x around the z-axis. The intersection of the cone with some planes are hyperbolas. We see it much better when we turn it. With this approach, we can also look at the cylinders, satisfying this type of equation: x squared plus y squared equals 4. All the intersections with horizontal planes are the same circle at center 0, 0, and radius 2, but at different heights. We get then the whole cylinder when we put all these curves together. If the intersection is with inclined planes, we get ellipses. Another surface that can be considered in this way is the ellipsoid. We see in the picture intersections with planes z equals some appropriate constant, or y equals a constant, or finally x equals some constant. The surface is then the union of these curves, which is the surface on the screen. And finally, we describe the sphere from a different point of view with respect to the previous surfaces. This is a generalization in the space of what the circle is in the plane, that is, the locus of points such that the distance to a given center is constant.